Let's see the next question, which came in GATE 2020 SAT 1 for 2 marks. A water supply scheme transports 10 mld million liters per day water through a 450 mm diameter pipeline for a distance of 2.5 km. A chlorine dose of 3.5 milligram per liter is applied at the starting point of the pipeline to attain a certain level of disinfection at the downstream end. It is decided to increase the flow rate from 10 mld to 13 mld in the pipeline. Assume exponent of concentration n is equal to 0.86 with the increased flow. In order to attain the same level of disinfection, the chlorine dose in milligram per liter to be applied at the starting point should be values this or this. Right. So what are they saying in the question? They are saying there is a source point and there is a final supply point, right? They are saying from source to supply, the pipeline is there and the length of pipeline is 2.5 kilometer distance. So the water supply scheme transports 10 mld water. So the water that is to be transported, it is 10 million liter per day, and the diameter of pipe is 450 mm. Diameter is the pipe of diameter. The chlorine dose of 3.Cl2 they are mixing in this 3.5 milligram per liter, so that it is sufficient to disinfect the water that we are going to supply from here. Okay, it is achieving a certain level of disinfection at the downstream end. Now they are telling that they decided to change the discharge from 10 mld to 13 mld. Same pipe, same length, that means same distance, they have to put the same the discharge at this only. So if we are changing the discharge, what will be the amount of chlorine that should be added to achieve the same level of disinfection that it was achieving at 10 mld? So this is the question. Now in this question there comes Chicks-Watson law. Chicks-Watson law. Now what does this Chicks-Watson law says? According to Chicks-Watson law, that it says that the chemical inactivation of the microorganisms species, that specific microorganism species, if we want to chemically inactivate these species, this is the function of the concentration of disinfection. First of all, we want to chemically inactivate, or simply in simple words, we want to destroy the microorganisms. To destroying the microorganisms, it is a function. Destroying a microorganism is a function of what? Concentration of disinfection used. Concentration of disinfection used and the time of contact. It is, these two are the major factor. Time of contact or contact time. Contact between the microorganism and the disinfectant. Okay, so killing of the microorganism is a function of the concentration of disinfection, the time of contact. More the concentration, more the time, more the killing of disinfection will work, right? Apart from this, it is also a function, destroying the microorganisms is also a function of the type of disinfectants. type of disinfectant, temperature, the pH of water, and the presence of suspended organic matter. Kind of disinfection, temperature, pH, suspended organic matter. So this is what the Chick's law relate about. Now, according to Chicks-Watson law, the rate of equation for the inactivation of microorganisms is given by Chick's law is given by dN upon dt, rate of equation of the inactivation of microorganisms is nothing but equal to minus k c to the power n upon c to the power n into n. Now what are these things? K is something, it is simply rate constant and it depends on the type of microorganisms. K is the rate constant, depends upon type of organisms that is used and type of disinfectant and the temperature. K depends upon type of microorganism, type of disinfectant and temperature. These are the affecting point. Now, what is N? N is the constant for a particular microorganism and type of disinfectant. N is also some constant for particular type of microorganism and disinfectant type, right? Okay. Now, what is C? C is the disinfectant concentration. That means concentration of disinfectant use. Concentration means weight per unit volume. Weight per unit volume. What is capital N? Capital N is the number of microorganisms present at any time t. Okay, number of microorganisms present at any time t. Initially, the number of microorganisms will be n naught. After some time t, it will reduce to n, right? This is the meaning of this. Now, for constant, if we assume constant concentration, C is equal to constant. Okay, concentration is constant at, that means we have put some amount of, some weight of disinfectant and that only amount of disinfectant we are going to use. So that is fixed. So if that is fixed and if we integrate this equation dN upon, if we just keep n this side, dN upon n is equal to minus k c to the power n dt, right? Both side disintegration, both side integration, and this side will become log ln n is equal to minus k cn constant t plus a constant of integration. Now at time t is equal to 0, n is equal to n naught, right? Time t equal to 0, n was n naught. So from here we can say C1 is equal to log of n naught, correct? So if we put the value here, log n upon n naught will come, this will become log n naught, and this side it will go minus log n naught, and minus log n naught means log n upon n naught is equal to minus k c to the power n t. From here we can say that n is equal to n naught e to the power minus k cn t. This is the statement, this is the equation for the Chick's law. Okay, now for particular degree of disinfectant, that means particular degree of disinfection, we say that n upon n naught is fixed, that we are keeping like disinfection 80% disinfection. Okay, this much disinfection is achieved. That means n naught the amount of n which is removed from n naught in 80% of n naught is fixed, right? So n upon n naught will be constant for a particular degree of disinfection. That means Cn upon T is equal to constant. Cn, c to the power n upon T is equal to constant. This is the Chick's law, and this is what we are going to use here in the question. In this question, they have said that the things that are given as are that length first of all in first case is 2.5 kilometers. Okay, area is 450 mm was the diameter, right? So pi by 4 into 0.45 square, that is 0.159 meter square. And discharge, this is area 1, and discharge is also 10 million liters per day. Concentration used at time 1 is 3.50 milligrams per liter. Okay, now in second case they are saying that L2 is 2.5 kilometer, area is also the same, A2 is also 0.159 because pipe is also not changed, right? Meter square. Discharge they are changing, Q2 they are making as 13 mld, and for both the pipes the n is equal to 0.86, that is fixed. And from the above equation we know that C1 to the power n T1 is equal to C2 to the power n T2. That means C1 to the power 0.86 into time we can say that time is nothing but L1 upon V1, velocity upon distance is nothing but meter per second per meter, so it comes to be second. Okay, is equal to C2 to the power 0.86 into L2 upon V2. Now see this V2, V1 is also, V1 and V2 is also can be changed. V is nothing but Q upon A, so Q1 into A1, and here it is also Q2 into A2. Now we know all the things we can put here. So C1 is the concentration, that is 3.5 to the power 0.86, length is 2.5 kilometers. And one more thing, see L1 A1, L2 A2 are same, so we can cancel it out and we got only 1 upon Q. So 1 upon Q1 is we can say the value of, let's say first we will put it as Q1 is equal to C2 to the power 0.86, 1 upon Q2. So C1 upon, this implies C1 upon C2 to the power 0.86 is nothing but Q1 upon Q2, that is 10 upon 13. This implies if we say C2 to the value is 4.75 milligram per liter. So if discharge is increased, the value of concentration is also increased to 4.75. So the answer is answer